Okay, well, let's keep trucking and try to play a little catch up since we weren't able to meet last week. Sorry about that. But that's okay. It looks like most of you are doing pretty well on the assignments. So I think any of you who struggled or came in with a smaller background in computer science seem to be playing catch up reasonably well. So hopefully I'll keep filling in some gaps, but so far so good. I'll take a look at the midterms as they come in. I know there was a problem with the very first question with an image, so just don't answer it, and I'll just give everybody full credit for it. I'll have to see what happened with that, but in any case, the midterm should give me a decent idea of what you're learning and where your weaknesses are. But so far we're doing okay, and everybody is starting to get all the assignments in on time, which means that I think most of you, as you're getting settled into the country and stuff like that, are have mostly played catch up. So I appreciate that. And if you are still a little bit behind and we haven't already spoken, reach out and we can chat about it. But I think so far things are going all right. All right, so before we dive back in, are there any questions for me up to this point?
No.
All right, so we're doing okay. Have any of you been watching any of the Winter Olympics? I'm guessing India is not very well represented in the Winter Olympics, are they?
Yeah.
Not a whole lot of winter sports in India. Maybe up in the northwest. Was that Kashmir? You have snow up there.
Yes.
Yes.
There was a movie a bunch of years ago. Some of you might be too young to remember, but it was called Cool Runnings. Any of you ever see that movie?
Yeah, Bag Milka Bag.
Yeah, so it had John Candy in it,
Yeah.
but it was the story of the Jamaican bobsled team. Pretty interesting, this if you haven't been to Jamaica, I would say it's a fairly similar climate to maybe like a Chennai. Kind of on the water, pretty hot. not a hot spot for bobsledding. But it was pretty interesting. All right, so let's jump back in here. All right, so last we were talking on, and I'll go a little bit quick here through it. I'm going to try to stop around 9 a.m. ish today, so we'll be cutting a little short, but let's so last we were talking about just kind of taking us through the history of kind of the internet, giving us the backstory for some of the networking stuff you've been looking at. I know over the last several weeks, you've already been looking at the TCP/IP protocol with the homework assignments, but let me see if I can close the gap as to the why. So last time we talked about this idea of modems. Specifically, the job of the modem was to convert an analog to a digital signal and back. This was to support that transition from our digital computers to the network, to another digital computer, let's say, over telephone lines, which were operating under analog. Now, eventually, we started using these guys digitally, which is where DSL came from and cable modems came from. We started having digital communication where we didn't need to do that conversion between analog and digital, yet we still tend to call those devices either a cable modem or a DSL modem, even though they're not doing modulation and demodulation anymore. they're still having to do some stuff, but not that stuff. But one thing we did talk about last time was the crazy modem noises, this stuff. So, you know, when you're, and I know a couple of you had said that you had done some dial-up before, and you know, you dial the phone number and your modem starts beeping and all that stuff. And what it's doing is it's called handshaking, and it is negotiating with the other modem to figure out what is the fastest we can talk with each other over this communication channel. Keeping in mind that, you know, it's there's all sorts of modulating and demodulating going on as the signal is moving between analog and digital. So the two sides are figuring out what is the fastest we can talk to each other, given whatever our constraints are, and not screw up, not make any mistakes. And the reason why not making any mistakes was important is because we did not have a governing protocol like TCP over IP for recovering from mistakes. So back then in the early days of the internet, when we had the modems doing all the beeping and stuff, that was because they were saying, what's the fastest we can go without messing up? Because there's nobody who has our back, no safety net. Okay. Talked about the history of our modems, yada, yada, yada. Talked kind of about the technology of DSL and, you know, how we started using a digital signal over what historically over those copper wires, which historically had just been used for analog. This allowed us to increase our speed, reduce the amount of modulation and demodulation, because we're no longer converting between analog and digital. Everything's just digital end to end. But we were having to use that same wire to do both our analog telephone service communication as well as our internet communication. So we needed to have almost like a micro example of our multiplexer and demultiplexer, where we were taking two signals and putting it onto a single line and then splitting it back out into the two signals at your house. Now DSL had some limitations where how far you were from the source of the network, because you would have single degradation happening over those copper lines, but it was still a major jump forward for internet connection speeds. Same time, cable modem services, cable companies started coming out with kind of the competitor to DSL. They suffered. A lot of them were already, you know, they already had digital networks and running over fiber optic, at least on the core part of the network. So they didn't have some of the struggles that DSL had from a distance perspective. So we kind of meld this in here. So we talked about DSL versus cable modem. Let me just add a slide here for cable modem. So this guy did not suffer from the same limitations as DSL, where there was a limit to how far one could be from the home office and still get internet. But it did have a few other limitations. So namely, and this is in the very early days of cable modems. So again, probably none of you experienced this, but we'll go ahead and ask the question. Did any of you have a cable modem in the very early days that cable modems existed? Keeping in mind that I don't necessarily, I know many of you are from India. I don't necessarily know how cable modems came into like when cable modems became popular in India relative to the United States. My guess is that you had them much later, so maybe this problem had already been solved. But did anybody have an idea what problem initially existed with cable modems? My guess is no, but figured I'd
Yes,
ask the
no.
question. Go ahead. All right.
When
Now,
you say, Dr. Lichtman, when you say cable modem, is it like a dial-up network?
no, we're talking about like so here it would be like your if you were using like Time Warner or Spectrum cable.
Okay.
Yeah, so the same companies that are giving you your cable TV, those guys, they started offering internet, and you would get a box called a cable modem, even though we've talked about those aren't actually modems because they're not, it's digital all the way across. But we still call them cable modems because the consumer associated the word modem with the internet.
Speed, the speed might be slow.
Okay, well, so certainly in the early days of DSL and cable modems, by our standards today, the speed was slow, but relative to dial-up, the speed was light speed, right? You know, dial-up was very, very, very slow. But something that was interesting with early cable modems, we're going to say early cable modems did not support two-way communication. And if you had cable TV in the, again, I'm talking about it from the United States perspective here. If you had a cable TV in kind of the early days of, let's say, high definition TV, you know, where you would get a couple of channels, or you had digital TV where, you know, you had like 300 or 400 channels, a much broader offering than I got when I was like a kid. Where cable TV was just starting to be a sort of kind of a thing, where you didn't have to use the rabbit ears to dial in see if you can get a clear picture. But in the very early days of having a cable box on top of your TV, one thing that you ran into was one thing they started doing is like allowing you to like rent movies, for example. All right. So if you wanted to rent a movie using your cable box at home, this is before cable modems, what you actually had to do is you had to plug a telephone line into the cable box. So your cable box would receive its download signal over the coaxial cable that carried all the channels with it and all that stuff. But if it needed to make requests back to the cable provider, like I want to rent Cool Runnings, connected to what we talked about here at the beginning of class, it would make that request over the telephone line, and then the download would come over the cable. The transmission would come in over the coaxial cable. All right, so this existed before we tried to use cable modems for internet access, where those set-top boxes over the cable company was only one-way communication. The cable company pushed data to us, that set-top box retrieved data. It could not send it. So early cable modems did not support two-way communication. A dial-up modem was required to make our internet requests, and then fast download occurred over the cable modem. So you still have to have your dial-up, you still have to have a phone line as part of it, but at least your downloads were faster using the cable modem. So it's fair to say that the very early days of cable modems were not very convenient. So even though cable modems delivered higher speed than DSL in the earlier days, it came with the cost of having to have an additional phone line, having to have a dial-up modem, having to have another internet service provider for making those requests. It just was not a convenient technology. Eventually, two-way communication became available, and cable modems took off. All right, so cable modems are generally faster than DSL. In fact, I mean, generally is not even fair. Cable modems are just flat out faster than DSL. I think we looked at some comparisons last class at like what AT&T or Verizon offered, and then what Spectrum's internet was, and we saw that the absolute fastest that that AT&T offered was like I think like 24, 40 megabits per second, something like that. You know, it was like less than 25% of the speed of the slowest internet that Spectrum sells. Now AT&T now offers, they offer it in downtown Milwaukee, and they're starting to expand this. They offer fiber optic now internet, so it's no longer using telephone lines. Their internet in some areas now are fiber optic all the way to the house. So now they were able to offer faster internet similar to cable modems, and maybe even in some cases beyond. But you know, now they're legitimately competitive at the fiber optic level, let's say, and a pretty good price point compared to the highest end cable modems as well. So places like AT&T are starting to catch up, partly because of what we're talking about here, where the early internet was based off the telephone systems, the POTS network, plain old telephone systems. And that was our first endeavor into the internet. Well, DSL today still uses that same network. So it kind of makes sense that that guy would have been dragging behind, because we were squeezing as much out of it as we possibly could until we just got, you know, passed up by the cable networks. Well, now cable networks, they're not digging up the whole neighborhood, laying new coaxial lines and stuff like that. So now the phone companies have been able to catch up, and as they've replaced their infrastructure with faster stuff, we've started being able to get better service, and that's just starting to happen now. What's kind of interesting about that, so let's just kind of finish this little comment here. Well, here, I don't want to forget about this. Is fiber from telco too little, too late? I'm just going to ask that question. That'll remind me of what I'm don't want to forget to talk about here. All right, so while cable modems, as soon as we got the two-way communication fixed, while they did not suffer from the speed limitations of DSL, relatively speaking, I mean, our cable modems have gotten faster and faster and faster over the years. But part of that has to do with limited bandwidth in the early days of the internet. So you got to keep in mind that we jumped from, 56 kilobit per second dial-up, and we jumped almost immediately to, 10 or 20 megabit per second cable modems. Well, this is in the very early days of the internet, whenever new technology first starts coming out, and now your cable companies or your telephone companies were starting to serve you the internet. They had limited bandwidth by today's standards, right? So what ended up happening is cable technology shared the bandwidth within a neighborhood. This means that if everyone was using the internet at the same time, it was possible that they would use up all of the bandwidth hurting the service of your neighbors. And this was even noticeable. It probably technically still exists today, but this was noticeable in some of the earlier days of high definition TV, where you had, maybe 90% of your channels were standard definition TV channels. And then 10% of them were high definition channels, and then, most people, they wanted to check out, as they got their high definition TVs, they really wanted to take advantage of these expensive TVs they got. So, you would tend to watch the high definition channels regardless of what was on. One interesting thing that I know probably for this audience, the preferred sport is probably cricket, right? But soccer is also kind of a outside of the United States, a pretty famous, sport, or, European football, however you want to call it. But in any case, some of the earliest high definition broadcasts were soccer. And I remember watching soccer on TV, even though I'm not a soccer fan, because that's what was available in high definition. So I do wonder if some of the popularity of soccer worldwide came from it being some of the early HD broadcasts worldwide. It's kind of an interesting thought. But unfortunately, cricket never really took off here in the United States. But I have been exposed to it significantly over the years. We had a cricket world championship watch party, I don't know, 9-10 years ago with our grad students. Trying to think who was playing. Sri Lanka. I think it was Sri Lanka versus India. And I think Sri Lanka won, if I remember correctly. But in any case, we had some really good Indian food at that party, and watched cricket as they were explaining to me how, trying to explain to me how the game worked. All right, so in any case, it was kind of an interesting thing that a lot of the early high definition stuff was soccer. I just distinctly remember that. But one thing you would run into, and this goes back to something we talked about much earlier in our slides, we were talking about multiplexing, right? We talked about it a little bit today. We talked about it from a generic network perspective, this idea of taking a whole bunch of signals and sending them over a single wire only to split them back out later on. Well, high definition TV used a lot more data than standard definition TV. Now, we still had a limitation. Well, we always are going to have a limitation on a network with how much data can be on that network at once, how much data that cable box can handle and split back apart, all those things. So really, you were fairly limited on the number of high definition channels that could be watched in a neighborhood at once. So it became kind of an interesting thing. So let's assume that there was 10 high definition TV channels available on my set-top box. I was on my TV messing around with the controller. I see my menu on the TV, and I have 10 high definition channels to choose from. Well, sometimes I would click a channel, and I tend to watch documentaries and things like that. So I might have been more attracted to some of the boring, like History Channel HD or something like that. So sometimes I would click a channel and it would say, this channel is unavailable right now, try again later. It wouldn't really tell me why, but the reality is other people in my neighborhood were watching high definition channels already. And let's say the limit was 4 in my neighborhood. So 4 unique channels were already being watched by people in my neighborhood. So if I had picked one of those channels, I would be able to get it. But otherwise, it wasn't broadcasting the channel I had requested to my neighborhood for bandwidth limitation reasons. So, this kind of stuff existed even prior to that, where, they were offering me 10 channels, but I was at the mercy of availability, whether I could watch all those 10 channels all at the same time. Now we typically don't have that problem because we have ways of fixing the bandwidth issue. We've expanded our networks and compression has gotten better and all sorts of things like that. All right, lots of different things. So getting to this slide here, well, let me just kind of put a bow on this. If I were buying internet today, and I can even tell you from this was a real thing. There was a period of time. Right now we have we use mostly streaming services at the house for TV. I probably would not get a normal TV streaming. I would just use Netflix and Hulu. I would just get the individual streaming services that I was interested in. But my wife likes some of those sitcoms and stuff like that. So we have YouTube TV at home now. So we use the internet. We use the streaming internet. Well, earlier than that, my wife really used the DVR a lot. She would record her shows and that kind of stuff. So we've always had some sort of cable TV, even if I didn't watch it. So there was a period of time there that we had AT&T Uverse. So that was AT&T's TV coverage kind of over DSL. It used that same telephone cable in order to do TV. But during that period of time, we did not use Uverse's internet. We kept using, it was Time Warner cable at the time, now it's called Spectrum. We kept using that for our cable modem because it's substantially faster. So my view, even today, I still use a cable modem at home today, is that cable modems are better than DSL. Sometimes you can get a lower price on DSL, but you're just not going to get the speed, not even close to it. Now that telephone companies are starting to catch up, let's assume that where I lived, which is about 20 minutes north of Milwaukee, so I live in one of the suburbs.
Sorry, I don't have an answer for that.
Shut up, Alexa. I live in one of the suburbs. If AT&T did have fiber optic internet available to me, I would consider switching over to that, because now the speed is a legitimate competitor with the speed I'm able to get at my house through cable modem. All right, all that being said, the question is fiber from telephone companies too little too late? Because now a lot of people have their cellular data plans, right? So it's pretty common nowadays, and you actually still see it on a lot of web forms you fill out, where it'll ask you for your home phone number and then your mobile phone number. And pretty commonly, we're putting the same number in both of those boxes because we don't have a home telephone number. You know, that what they're really talking about is your landline that would be at your house. And most of us don't have that anymore. I haven't had a landline at my house in years. We finally got rid of it when we stopped using, you know, a fax machine. You know, is that kind of thing. And so we were maybe late holdouts where we got rid of it later than a lot of people did. But now we have our cell phones with us all the times, and that's our the way you reach us, by telephone. Well, similarly, data plans for our smartphones have become more and more reliable, more and more low cost. Now they're, you know, doing things with unlimited data, or at least enough data where if you didn't abuse it, it would last you the whole month, that kind of stuff. So there's a legitimate competitor now, probably not quite at price point to compare, you know, choosing to just use your cell phone as your internet at your house versus getting DSL or a cable modem. But cellular data plans have been getting better and better over the years. So we had 3G, then we had 4G, yada, yada, yada. And mixed in there, we had a couple of different technologies. We had GSM versus CDMA. So GSM was AT&T, what AT&T used. CDMA is what Verizon used. And then, you know, if you've had cell phones and these kind of things, if you had a phone that was capable of talking on AT&T's network, it was also capable of talking on T-Mobile, and you know, overseas there was a bunch of different networks that T-Mobile's pretty big over in Europe. They all use that GSM technology, where Verizon and Sprint and several other companies, they use the CDMA technology. GSM required more towers, CDMA required fewer towers, but GSM had lower latency. So again, we're basically talking about a wireless network. So without getting too much into the details of these guys, we had two competitors for how to deliver a wireless network. Ultimately, we came into an LTE technology where most of those networks started using LTE. Several of them still had the old transponders on them as well to support older phones, but effectively all of our networks today are using LTE, even if it might be proprietary. I think typically, and this changes, this has been changing for a while, but historically, if you were going to get a single device, a single smartphone, you would be better off getting a Verizon unlocked phone than an AT&T unlocked phone. And it's because a Verizon unlocked phone had a radio in it that was capable of speaking both GSM and CDMA. Where an AT&T unlocked phone, let's just talk iPhones here. An AT&T unlocked iPhone only had a GSM radio in it. So if you had the Verizon version of the iPhone, you could take that to any network, period. Where if you had an AT&T one, you were limited what networks that hardware would work on. That's becoming less and less of a thing now that LTE has pretty much taken over. You know, so we had our 4G, and now we're starting to hear them talk about 5G. So again, 5G, without going into you know, details of the stuff about it, we talk about that some of the advanced networking class, is 5G delivers very high speed internet wherever you are. Legit competitor to home-based internet, to the point that we will likely see people having 5G as their internet everywhere. All right, this is becoming kind of the next thing. So the fact that our telephone companies like AT&T are just now starting to get things like fiber optics and stuff like that to give high speed into the house. You know, like I said, right now in this area, that's only available in Milwaukee downtown, is slowly moving north, so it hasn't quite gotten to me yet. By the time it gets to me, I'm probably going to have the choice between that and a 5G based wireless internet that probably exceeds it in speed, and I don't have to worry about whether they have cables. So the punchline here is things are moving from physical cables towards wireless signals, and we've seen that for many years. If you are a computer gamer, a lot of times if you're like a big time PC gamer or something like that, your preference would be to have your computer plugged into your DSL or your cable modem through a wire instead of wireless, because you have a little bit lower latency. Probably not noticeable for a majority of us, but if you're a professional level video game player, perhaps you would notice a slight improvement of being on a wired connection versus a wireless connection. All right, so we're probably about to bust into the next generation of our internet through this idea of 5G, and it has, in my view, it has little to do with how amazing 5G is, and has more to do with the adoption of wireless networks and their equivalent speed to our wired networks with hopefully competitive costs. Let me move this back up to where DSL was. Then we talked about cable modems. All right, so I had mentioned that in the early days of the internet, while our modem was sitting there negotiating with our with the other modem it was talking to, it had all that beeping and static and things like that. It was attempting to figure out what is the fastest speed we can talk to each other without screwing up. So punchline there is it was very, very, very important for network communication in the early days to not make any mistakes. All right, now we can say that computers are relatively good at doing mindless work and not making mistakes. But now when you have wired connections between computers, there are things that can interfere with wired connections. For instance, magnets, electricity, things like that can cause interference with them, which could introduce some corruption. Similarly, depending on the nature, let's create a slide here. Call this guy network interference. So we have external interference, like magnets and electricity, that might impact the physical cable. Then we have internal interference, depending on the technology. Serial versus parallel. All right, so we've had the idea of serial ports and parallel ports on our older computers. So for example, our modems, our dial-up modems, they would typically connect to our computer, the digital side of that communication, through a serial connection. Whereas like our printers back then would hook into our computer through a parallel connection. So serial versus parallel really talks about the mindset of how data is sent across a the mindset of how data is sent across a cable. All right, so serial, right? I think that's right. Sends data 1 byte, or we could say 1 bit at a time, depending on the technology, so that there isn't a split or need to regather the data. It arrives in the order in which it was sent. Parallel sends data multiple bytes at a time, where the source data needs to be split up and put back together in the end. at the end of the day, you can think of this as kind of like roads. So this is like a single lane road. This is a multi-lane road. With single lane roads, you might be limited on how fast you're going by how fast the guy in front of you is going, but there's no choice of passing them or anything like that. In a multi-lane road, technically more data can be moving at once, but you have congestion issues on either side. All right, that makes some sense. So we might say might be slower, but less error prone. Fewer accidents, we can think about it like that. Might be faster, but more error prone. So as we started thinking about, okay, we have computers that want to talk to each other. So we have to ask the question, why does networking exist? All right, so it asks, why does network exist? Well, in the early days of computers, we were perfectly happy just using our computer, only stuff currently on the computer, maybe sending it to our locally connected printer, that kind of stuff. That was normal common use for computers. Well, as computers became more prevalent and we had more and more offices using computers, and they had multiple computers in the office on different people's desks, we started seeing, oh, well, maybe there's a need to have like a central computer that stores all the data, or stores shared data for the business, let's say, and we need to have some way of having that data available to the people on the other computers, stuff like that. So networking was born out of a need / desire to share data between multiple computers, as having multiple computers became more and more common. Now, as human beings do, when we get, we're never happy, we're very greedy. So as soon as we get one thing, we want more and more and more. So in the early days, we had the idea of a local area network, where we were only connected to the computers directly near us in the physical world. Then we had this other thing, and this was something nobody ever really talked about, but the idea of a municipal area network. Connected to the computers in a larger area, maybe like a college campus or town. Then we had the idea of a wide area network. Connect computers across large distances together. And we can probably say that the internet is a collection of networked WANs, which is a collection of networked MANs, which is a collection of networked LANs. Something like that. If I think about here on campus, I can walk into our computer lab in computer science, and there's a local area network. All those computers are connected to each other, but then that LAN is connected to the larger municipal area network that the university runs. we have 3 or 4 different computer labs, and then all the faculty members might have computers in their office. Now, most of us are running around with laptops, just like most of the students are. So, so we have a couple of different wireless networks on campus that give you access to different things. So, this is kind of the idea is, as we wanted to have more and more computers talking to each other, we created more and more ways to do that. So that's the why behind the networking. So then we say, how did we accomplish networking? Well, before we had wireless, we had to have wires connecting all of these various networks together somehow. Now, when we talk about wires, we are really talking about 2 separate things. So wires, when we say wires, we are talking about 2 things. One, what kind of physical cable is this, and what are its limitations? 2, what protocol will we speak over that physical cable, which best takes advantage of its limitations? All right, so really 2 different sides of things when we talk about the media part of the physical network connection part of networks, or as you probably have read about more recently, is the idea of TCP/IP. Okay. So if we just jump ahead, you have this history of networks with ArcNet, and Token Ring, and all these different things, but popular network, it's called Ethernet. So most of our modern day networks are based on the Ethernet protocol. Now, most of you at some point have probably heard of Ethernet. What can you tell me about Ethernet? Anybody have some nuggets of knowledge that you can share about Ethernet?
It connects the local network.
Okay, connects various networks. What about the behavior of Ethernet? We go back to this idea of serial versus parallel. Is Ethernet a serial technology? Is it a serial protocol, or is it a parallel protocol? So Ethernet is a protocol. Let's call this Ethernet protocol. So it's the language that we're choosing to speak over that wire. So is Ethernet a serial or a parallel protocol?
It's parallel protocol, Dr. Rickman. It can send data both ways.
Okay, we can send it both ways. So when we talk about sending both ways versus one way, we're talking, there's another term in networks called duplex. So we can have full duplex, half duplex, or no duplex. But yes, Ethernet can send both ways. It is, data is sent. Let's see, I want to say it this way. We can think of Ethernet as one big multi-lane highway where data flows in both directions. This is often called the bus. Okay, so Ethernet is a bus-based protocol. So data is flowing in both directions, but it's multi-lane. Because it is multi-lane, lane and the data may be traveling very fast, there is a risk of collisions. A collision can cause data to become corrupt. All right. So if we think about this like we're driving, if we have a 6-lane highway with cars going both directions, if everybody has a Ferrari and they all just stepped on the gas and they're going as fast as possible, you're increasing your chances of a car accident, right? Whereas everybody's going super slow, we can be a little bit more careful. Yeah, it's going to take us longer to get to our destination, but chances are we're going to have plenty of time to react if somebody cuts us off or something like that. So the faster we're driving, the more dangerous things are. All right, so a collision, just like it is on the interstate, is bad, right? If you get in a car accident, hopefully everybody's okay, but they eventually tow your car away, and then that has to be repaired before your car can get back onto the road, that type of thing. All right, so Ethernet is considered a very good protocol, but it needs some level of oversight to ensure that data always arrives at its destination. Because sometimes there's going to be accidents. Sometimes there's going to be collisions. And we want to have a way of recovering from those collisions. So welcome TCP over IP. Let's see, where am I at here? I had a picture. So that's TCP over IP. This is transport control protocol over internet protocol. So we have two separate things happening here. Okay, transport control protocol is dealing with data flowing over a cable. Internet protocol has more to do with the applications using that data, kind of on the larger scale of the internet, talking about DNS and things like that, which we're going to talk about probably next class. All right. So having said that, now I'm just going to put something underneath here. This guy is based on the OSI 7-layer model. TCP compresses this to 4 layers. But the reality is all the same crap is happening. So, it's not like we did something something new and exciting, but these are the OSI 7-layer model was an original approach to this. TCP over IP was kind of an internet focused approach to guaranteeing that data eventually arrived and could be put back together at its destination, even if there were collisions. All right, so we see here's kind of a couple different ways of visualizing TCP. So we have this OSI model. So you have your physical layer. So that's your cable. And that guy has to be linked. Well, the physical and data link layer. This is the hardware at your computer along with the cable, and those things need to be linked together. Then things flow over the network. Their flowing is through transport. Session is in presentation, or maybe these guys are probably individually hard to necessarily explain, which is why TCP puts them all into one category. So here are the pieces of software that are using network data. Okay, here is the actual transmission of data between hosts. Here's the physical highways those things are flowing over. And then here's what's on either computer for interfacing with those highways. These, you can think of these like the on-ramps, something like that. All right, so if you kind of look at these different levels here, we have, you know, Ethernet, token ring, frame relay, ATM. We've just been talking about here Ethernet. So these are our network interface layer. So what protocol are we going to be speaking on this network? All right, then we get up to this idea of IP, Internet Protocol. So we're probably going to be speaking the language of the internet over this guy. We have two different ways of communicating with TCP IP. One of them is, well, it's actually not TCP, it's TCP versus UDP. And we'll talk about that next time, the difference between them. TCP is a, you know, TCP protects the data, resends corrupt data. UDP allows for corrupted data and doesn't resend because the application that you're using over UDP wouldn't benefit from that. So think of it like streaming video. If you're watching Netflix and one frame of your movie gets corrupted, you don't want the whole movie to pause while that frame gets resent to hopefully give you that 1 out of 60 frames for that second looking a little cleaner. You'd rather just skip the frame and move on with life to give you the best end user experience. So we have a couple different mechanisms that we can choose to use over Internet Protocol. And then we have our applications that we have sitting on top of Internet Protocol. We have Telnet, FTP, SMTP. We'll talk about these guys. DNS, RIP is a router protocol. So in any case, these are kind of, we're seeing our modern day networks through the lens. So this is this TCP IP thing is right here. This is the picture of this guy. And here's another way of looking at this. So here's the protocol. Here's our unique way of talking about our different computers. Every network interface card has a MAC address. Think of it like a unique phone number of your card. Then you're on the internet. So we can uniquely identify a network interface card through its MAC address. Similarly, we can uniquely identify a computer on a larger network, also a smaller network, and that's where we're going to be talking about this idea of a NAT. We can get that through its IP address, and we'll talk about IPv4, IPv6. So let me get to that. All right, then we decide how are we going to protect the data. Is it protected with TCP or is it unprotected with UDP? And then we ultimately think about, okay, what applications are we using? What's the nature of the data and how do we recombobulate it on the end? All right, so this picture here kind of gives us a view of how the internet exists today. And we're going to, over the next couple of classes, we're going to talk about the inner workings of these things, even though through the homework assignments, you guys have already been looking at these individual layers. All right, so what I'm going to be attempting to do is give you the broader picture of how these layers all work together to accomplish the full task of making the internet work. All right, so questions about any of those things? All right, so that's a good stopping point for us today before we jump into something, the next kind of step. So we'll pick it up on Wednesday morning, 8 a.m. I will try to get the, and I think I had told everybody that I just needed the midterms in by the end of this week. So if you haven't done it yet, that's okay, but I'll grade them as they're coming in. So you kind of get some feedback on, what you're learning and things like that. But so far, keep up the good work of getting the stuff in. I know everybody's kind of still, a couple of you I know are looking for housing and stuff like that. So we'll roll with the punches pretty well and hopefully get everybody all settled in by the end of this 8 weeks so that we can have a nice clean start to the next class too. All right, questions, comments, concerns, bribes. Okay, I will see everybody on Wednesday morning.
Thank you, Professor.
Yeah.
Okay, so
Have a good one.
thank you very
Take
much.
care.
Bye,
You too.
Dr. Letman.